Stop, please. And last time, the kind of main thing that I wanted to get to was just showing this idea of an inverse. And we're going to use that inverse to be able to help us to graph logs, right? Logs, it's still a hard idea for us to kind of understand, right? It really takes this whole unit before we start to get the idea of what a log is. And really, it's just the inverse of an exponential. Okay, so anytime we're seeing logs, we're basically thinking about them in terms of exponentials. So last time, we just talked about, one, how to find an inverse. That's switch the domain and range. And in an equation, I can switch x and y. And then to solve for y, we had to do that conversion from a log form to its exponential form. We're not going to show this work every time, but what we are going to do is we're going to be given a log equation, and we're going to need to figure out what would its inverse exponential be. It's always just going to be whatever the base of the log is. So it'll be the base of our log. That's going to be the base of our exponent. So that's always our starting point. Get it to be an exponential because we're more familiar there. Then we'll switch the x's and y's to get the log, and then apply any transformations just like what we did when we graphed exponentials. So let's actually start on this next page and work on graphing log base 2 of x plus 8 plus 4. All right, so like exponentials, and really every function that we've graphed, there's transformations based on the parent function. The parent function of this graph would just be log base 2 of x. So everything else in here is doing something different to that parent function. We're going to identify any horizontal or vertical shifts. Remember, the number being added or subtracted to x, it will always be your horizontal shift, right? If it's happening to x, it moves like x moves, which is horizontally. In this case, the sign is opposite. So this is taking everything and moving it left 8. Then that 4, anything that happens after the operation here is us taking the log of x plus 8. That's going to affect our y values. Y values move up and down. So this is shifting everything up 4. And just like we did with exponentials, to account for these shifts, we're going to create our new axes, okay, the new origin. So I'm going to take this y-axis, I'm going to shift it left 8. And then I'm going to take the x-axis, and it's going to shift up 4. And we're going to pretend that this is our new origin. It's really not, but we're just going to pretend. Okay, this is how we're accounting for the shifting left 8 and up 4. All right, now to get the actual points or the actual values from that we're going to plot here. Yes, we're trying to graph log base 2 of x plus 8 plus 4, but we're going to first convert it to its inverse. The inverse is always the base of the log, but to the power of x. So that base to the power of x. And we're just going to list out the values here. Okay, 2 to the power of negative 2 is 1/4. 2 to the power of negative 1 is 1/2. Anything to the power of 0 is 1. And 2, then 4. So what we just did is we came up with points. We have given x values, same x values we use when graphing exponentials. And we have y values for the exponential, which is the inverse of this log. To get our values of the log function, which we're actually trying to graph here, we're just going to switch the domain and the range, or switch the x's and the y's. So this is x. And then this next column, we're going to call this log base 2 of x. And all that we're going to do is we're going to take, these are essentially our y's. These become our new x's. So this is our range becoming our domain. And the x's become the y's, or the domain becomes the range. So this is negative 2, negative 1, 0, 1, and 2. This is 1/4, 1/2, 1, 2, and 4. These are the points that we're going to plot from that new origin. Angel, do you mind shutting that door for me? Thank you. So from this new origin, I have an x value of 1/4, so that's barely to the right, and a y value of negative 2. So 1/4 to the right, down 2. Then 1/2 negative 1, that's right by half, down 1. 1, 0, that's right 1 and not up or down at all. 2, 1, that's 1, 2, and then up 1. And then 4, 2, that's right 1, 2, 3, 4, and then up 2. And there's our graph of f of x, okay, which is accounted for all the shifts. And it does kind of have a similar shape, just rotated a little bit as an exponential function. So some differences here. With exponentials, we had a horizontal asymptote. Well, with this now being the inverse of the exponential, instead of having a horizontal asymptote, we get a vertical asymptote. And that actually matches up with something we talked about yesterday, in that we can't take logs of negatives, right? If I'm trying to take log base 2 of, let's say, negative 4, I'm thinking about this as 2 to the power of what is negative 4. Let's set it equal to x and do the conversion. Well, is there any exponent that's going to allow me to get this to be negative 4? No, right? Negative exponents don't make the value negative. They just make it smaller, or I guess if the base is a fraction, they make it bigger as well. Okay, so this is not possible. And so with logs, it's our domain that's restricted. Okay, as opposed to exponentials, we don't have any restrictions on that domain. So our domain here, and this can show up in 2 places. The graph, the furthest left that we're getting to is negative 8. And then it goes all the way right to positive infinity. Well, that negative 8 is showing up in the actual equation. Okay, so we should always be able to figure out the domain even without the graph, just knowing that we can't take logs of 0 or negative numbers. Okay, so the smallest number that works here is like negative 7.999999. List 9's all you want. Okay, but as soon as we get to negative 8, we get in there. That's why we use that curved bracket there. All right, then for the range, the domain of an exponential was negative infinity to positive infinity. So when that switches to become the range of our inverse, which is this log function, it's also negative to positive infinity. Okay, remember that the y values with logs are the exponents when we think about them in terms of an exponential. Every number can be an exponent. So for every log, your range will always be negative to positive infinity. It's the domain that becomes restricted. Okay, any questions thus far? Okay, well, let's switch it up and add one more transformation to this. And I'm going to have you all do a couple on your own. Number 2. Let's identify our shifts. So we're taking every point and it's going to get shifted left 4. Remember, that's always an opposite sign. Then everything also gets shifted down 2. While we're at it, we might as well draw our new axes. And this is our new origin. And so the only transformation that we haven't accounted for yet is this 3. That 3 is our stretch or compression factor. So with that being greater than 1, the graph of log base 2 of x is going to be vertically stretched out. I'm not asking you to name that as we graph these log functions, but that's still making connections to transformations we've talked about. That was way back first semester. So I still want us to identify it if we can. How we're going to deal with it is we're going to actually use this last column to account for that 3 there. So again, our starting point has us taking the inverse function. So we're going to take the base of the log to the power of x, so 2 to the power of x again. Same values that we got previously. So 1/4, 1/2, 1, 2, and 4. Then we're going to start by making a table of values of just the log base 2 of x, not with that vertical stretch yet. We'll deal with that in a second. So this is where we're going to switch the x's and the y's. Y's become x's, x's become y's. And then we have one more thing to do. The last thing that we need to do is figure out how are we going to apply this vertical stretch of 3. Well, what's happening is the x is not changing at all, right? We're still taking log base 2 of x. It's just that log base 2 of x then is going to get multiplied by 3. So how we account for the 3 is we multiply all of the y values by whatever number we have here. So this 3 is telling us to multiply y by 3. So the x's stay the exact same, being 1/4, 1/2, 1, 2, and 4. All these y values are going to get vertically stretched as we multiply them by 3. So -6, -3, 0, 3, and 6. And it's these points that we're going to plot from that new origin. And then we'll have our entire graph. So right 1/4 and then down 6. 1, 2, 3, 4, 5, 6. 1/2, halfway, and then down 1, 2, 3. We're going to always get that 1, 0, and 2, and 1, 2, 3, and 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And eventually it'll kind of flatten out there. But yeah, I think this page gives a pretty good visual as to how that 3 is really stretching the graph out, right? In the first graph we did, it was still log base 2 of x, but if you look at how much graph we're seeing, it's much more compact, right? This one that we just graphed, all those points have really been vertically stretched apart. Now for our domain, again, the 2 places you can check the graph. We'll never go further left than -4. That is also showing up in the equation here. So it's -4 to infinity. And then the range, always negative to positive infinity. All right. Any questions? Okay. Let's go and flip this over. I hope I mixed in. Oh, yeah, I did. Good. All right, I am going to ask that you all work through these next 2. But we got to remind ourselves about a couple things. I don't see a base here. What's the base? Thank you. It's base 10. Might be worth just filling in. That way we know where to start. Then, and I've heard this from a few of you, we're like, natural logs. We're forgetting about natural logs. Remember that natural log of x is simply just log base e of x. Okay, it just tells us what the base is. So we could rewrite this entire equation so that it is log base e of x plus 4 minus 2. And you know what? Let's do this. Let's add in a vertical stretch here just so that we get that last column used. Let's just do a -1. So let's call that negative log of x plus 8 plus 3. Okay, so that way you have to use all the columns. All right, do your very best to see where you come up with. Maybe we'll do this in 2 parts. I'll work through this third one. We'll check it, and then I'll give you some more time to work through number 4. But if you get done with 3, go ahead and just move on to number 4 as well. All right, give you all a few minutes to work through these. Let's check number 3 real quick. If you're not done with it yet, don't just write down what I have. Kind of take a look here. With this base being 10, it's going to grow really quickly. So when we get to 10 squared and you get 100, we're not going to be able to plot that point. I still want to see it in your table though. So your 10 to the power of x values are 0.01, 0.1, 1, 10, and 100. Then I switch the x's and y's to be able to come up with values for my log of x. Then that negative has us multiplying all those y values, or all the values that we get by taking log of x, and we're just multiplying by a -1. So it reflects that graph across that new x-axis. And this one gets flat pretty quick because, again, of how quickly we're growing in this exponential form, and thus how slowly we're going to grow in the log form. Then your domain is negative a to infinity, and the range, as always, is negative to positive infinity. All right, again, on the next one, you're going to need a calculator to find values of E. Remember to access that button. Oh, I don't have a calculator next to me. Oh, here we go. Almost all your calculators, the E button should be the exact same place. It should be the second option of the natural log button. So you've got natural log right there. If you press second and then that natural log, it'll give you E and then whatever exponent you need to take it to. Okay. Do your very best with number 4. You know what? Let's once again just add another A value just so we're getting in that habit. Let's make this 2 natural log of x plus 4. If you've already done without it, you don't need to redo it. Okay, but if you haven't done so, take all those y values, multiply them by 2. So we get a vertical stretch there. All right, a few minutes, and then, yeah, come around with homework. Still having trouble with the values of E, definitely let me know. That way we can get that figured out. Natural logs and E's are going to continue to show up in the next couple of lessons as well. So e to the power of x, and I know we don't talk about rounding in here, but when rounding, try to pay attention to when you should round up or down. I'm rounding to 3 decimal places, then 2 decimal places. Let's just say standard is at least 2. Okay, the more you do, the better, but at least 2 doesn't make a huge difference because it's not like we're plotting exactly at 7.39. Okay, so nothing I'd be picky about, but still little things we should still be mindful of. All right, so we got all our values of e to the power of x. Then I get my values of the natural log of x by switching the original x's and y's. Then we did change this equation so that it's 2 times the natural log of x. So all these y values get multiplied by 2, thus stretching this graph out. And we can see that on here. And then we have a horizontal shift of left 4 and a vertical shift of down 2. So your new origin is at -4, -2. Domain is -4 to infinity. Again, nothing, just because it's a natural log doesn't change anything about it. It's all the same. And then range is negative to positive infinity. All right. Any questions? Okay, well, the rest